I'm going to show you my answer. I'm going to show you both my answers. I'll show you the algebra, and then I will show you what made someone even think, like, why would they do that? There are lots of steps where, just like in a classic trig identity proof that's quite hard, they're like, oh, I'm going to add and subtract the same thing. It's like, well, why? Okay, so here's the way I'm going to do this. Now let's rewind to all the proofs that you've ever needed to do in the 2-unit and Extension 1 course. Think about geometry proofs, think about induction proofs, of which, this, if you try to do this via induction, that was not a bad idea, because like, oh, proofs, that's the only context I've seen inequality proofs in before. There's a kind of red flag though that tells you induction is not going to be very helpful here. Can anyone see what the red flag is?
There's 3 variables.
Right, there's 3 variables. That's a problem, but it's not like, it doesn't rule you out, right?
Because A, B, and C are not integers.
Ah, so I know A, B, and C are all positive, right? They're all positive, but they all add up to 1. So that means they're all fractions of some kind, right? So this is going to be a bit of an issue. Like, induction's primarily dealing with whole numbers, right? So even though that's not ruling us out completely, it sort of indicates to you, are there other ways? Okay. So, thinking about all the proofs you've ever had to do, one of the key things is you should always start with what you know, and then try and move towards what you're supposed to prove, okay? Now, you know precious little in this question. In fact, you only know 2 things. You only know that they're all positive, and they are successively bigger or smaller than each other. And then you know that there's this relationship, there's this sum, okay? So I kind of have to choose one of those as my starting point, or something else that's what we would call axiomatically true, like the square of real numbers are always positive or 0. Can I use one of these, okay? Would someone like to suggest which one of those would be a good starting point to use? Number 1 or number 2? That's interesting. I've kind of heard both. I've heard both. And there are sort of clues in both of them that would lead us towards saying, yeah, this is worthwhile. For example, what's this one got running for it that makes it like, oh yeah, I'd rather work with this to get there? What obvious thing is there? Say that again?
It's an inequality.
It's an inequality. Yeah, thank you, right? So if I can just set this, I can just sort of twist and turn this. I've already got it in an inequality form. And then maybe I'll substitute this in somehow, okay? That's what this has got going for it. What about this? Some people who said number 2. Who said this one and why?
It's got a 1 on the other side, so you can make it
Good.
equal to 1.
Yeah, fantastic. So remember, we're still at this point where we're like, I'm sort of like firing off in random directions, and I don't know where I can go. I've seen the inequalities over here, and then I've seen this 1 over here. Okay? Which one do I go with? Now, I'm going to go with number 2. I think it has a bit more in common. Not only does it have this 1 in common that you've just noticed, it's a little bit hidden, but it's got A, B, and C all together, right? And it's also a sum. Do you notice that? Okay. So I'd like to try and work with this thing. So this is my starting point. Okay. So if I'm treating A plus B plus C equals 1 as my first line, what would be the most obvious thing I could do to try and get from here to here? And someone asked this already, right? I think squaring is a great idea, right? Because all of those things are squares. Nothing over here is a square. So why don't we square things? I've got a left-hand side. I've got a right-hand side. Let's just try this, okay? So I'm going to write it like this. Square the left, square the right. Everything's looking good, okay? So this is fine. Let's push on this a little further. A plus B plus C, you can memorize this if you like, but I don't think there's that much point. There's a nice easy way to remember what this result is, but I'm not going to show it to you yet because it'll spoil my next step. This expansion is A squared plus B squared plus C squared. I think that much is obvious, right? Because you're eventually going to multiply this by itself, and this by itself, and this by itself, right? If you want to think about it in terms of perms and coms, right? This is this, right? So how many ways are there to choose the A twice? There's one way, right? How many ways are there to choose the B twice? One way. And how many ways are there to choose the C twice? Okay. But then when I say, oh, how many ways are there to choose an A and a B in any order? Because when I write algebra, it doesn't matter. And the answer is there's 2, right? I could go A and then B, or I could go B and then A. Right? And there will always be 2. There's going to be 2 of every other combination as well. Okay? So from that corollary, I'm going to say this is 2AB, 2BC, and 2AC. Okay? Of course, you can just, machine the algebra out if you like. But I prefer seeing that, hey, there's a link between algebra and perms and comps. That's kind of neat. Okay? So far, so good. I've got two things that are good and a few things that are not so good. Okay? I've got some a squareds, b squareds, and c squareds. Thumbs up. I've got a 1. Also a thumbs up. But then I have two problems. What are they? Okay, yeah. I got all of this fluff, which seems to have nothing to do with the result I want. And I have an equality, not an inequality. Okay, so I'm on the right track though, because I know I've got so many pieces here. So I've used one piece. I tried to push on that a little bit. This guy looks like it must be important, right? So how do I use him? Well, I'm going to use this in one fell swoop. And again, you'll ask the question, how did I know how to do this? Well, once I show you the second method, it will become apparent. I'm going to note that these guys can be transformed. I can transform these into other things and put an inequality in the place of an equation. Okay? Here's how I'm going to do it. I'm going to notice that, since, I'll write it this way, B is less than A. Right? A is the biggest one, B is next, then C, they're all positive. Since B is less than A, and all of the numbers are positive, right? I can multiply this inequality by any of these numbers I like, right? Because they're all positive and it won't muck with the inequality or anything like that. So for instance, I might multiply through by B. Do you agree with that? Is that okay?
Oh my god.
Okay, do you see it, right? Maybe that's all you need. But you see now, right? You see how I've got two ABs there, right? Well, these ABs are both going to be bigger than B squared. So I can say this. A squared plus B squared plus C squared, right? If I replace that with a B squared, well, B squareds have to be smaller than ABs. So this thing, if I just put the rest of it in, this thing is not equal to 1 anymore. I replace this piece with something smaller than that. So it must be smaller than what the original line was. Do you agree? Okay. Maybe I don't need to go any further, right, in terms of showing you, but you know where to go now, because look, there are 3 B squareds now. 3 B squareds. Right? So I'm going to say, well, that's A squared plus 3B squared plus C squared. And then you're like, well, what do I do with these guys? It's like, well, since, I'll finish writing it, like so. I can make the same argument, right? Since C is less than B, C is less than B, what would you like me to write next? C squared is less than BC. And similarly, C is not just smaller than B. C is also smaller than A, right? Smaller. Okay. So therefore, again, I'm going to square it like that. Is that okay? So these BCs and these ACs, I'm going to replace each of them with something smaller, namely C squareds, right? So therefore, A squared plus 3B squared plus C squared, plus these guys, still less than 1. And I'm not even going to write the last line because that's the last line. Okay.